Today we are going to revise a technique that you learnt about in Year 9 called trial and improvement, which is used to solve equations. You've come across a number of different types of equation in maths. Linear equations can be solved by rearranging to find x, or your unknown, for example by subtracting 2x from both sides, multiplying both sides by 2, taking 3 from both sides, etc. This is an example of a linear equation. 3x plus 4 equals 2x, take away 5. You've also come across quadratic equations. These can be solved by factorising or perhaps by using the quadratic formula. For example, x squared plus 3x plus 2 equals 0. What about x cubed plus 2x equals 10? Now this is a cubic equation. The highest power of x is 3, and we're going to need a slightly different approach in order to solve this equation, which is where trial and improvement comes in. You're going to need to set up a table. The first column is for x values. The second column is for values of x cubed plus 2x, i.e. you substitute the values of x into this expression, x cubed plus 2x, and the third column is for a comment. Now remember, our target is for x cubed plus 2x to be equal to 10. I'm going to start with a value of x equals 0. If we substitute 0 into x cubed plus 2x, we would do 0 cubed plus 2 times 0, which of course is equal to 0. So our comment, we compare this value of 0 with our target of 10, and this is lower than the target, so I'm going to write a comment of low. I'm now going to try 1. So I'm going up in a whole step. I'm going to do 1 cubed plus 2 times 1, which is equal to 3. This is still lower than 10, so I'm going to make the comment low. I'm now going to sub in a value of 2, again going up in a step of 1. So we have 2 cubed plus 2 times 2, which is equal to 12. Notice this is higher than 10, so I'm going to write in high. Now, because 1 gave us an answer that was a little bit low, and 2 gave us an answer that was a little bit high, the real answer must be somewhere in between 1 and 2. Now, I'm going to be sensible and logical, and I'm going to choose the middle value of 1.5. So I would have to do 1.5 cubed plus 2 times 1.5, which equals 6.375. Now obviously this is a little bit low. Now at this point I can see that because 1.5 was a little bit low and 2 was a little bit high, that means the answer must be somewhere in between 1.5 and 2. So I'm now going to take a logical step and check 1.6. There isn't enough space to show the substitution at this point, so you can just work it out on your calculator and write down the value of 1.6 cubed plus 2 times 1.6 in the space here. The value is 7.296, which of course is still lower than 10. So that means we're still looking at a number in between 1.6 and 2. So I'm going to try 1.7. So I'm going up in logical steps of 0.1. Trying 1.7 gives me a value of 8.313, which of course is low. So I'm going to try 1.8. This gives me a value of 9.432, which is closer to 10, but still a little bit low. So we're going to try 1.9. a value of 1.9 gives me 10.659, which is interesting because this is now high. So we can see that 1.8 gives us a value that's slightly lower than 10, 1.9 gives us a value that's slightly higher than 10, so our answer has to be somewhere in between 1.8 and 1.9. Now, we could carry on doing this for a very, very long time, making the answer more and more accurate. And if the answer is an infinitely long number, then we could be here for a very long time. So in a trial and improvement question, you will always be asked to give your answer to a particular degree of accuracy. So, for example, you might be asked to give your answer to 1 decimal place. Now, it's important to understand here that this does not mean give these values to 1 decimal place. It means find out the value of x to 1 decimal place, i.e. is x 1.8 to 1 decimal place, or is x 1.9 to 1 decimal place? How do we decide between them? Now, this is the crucial last step in a trial by improvement question, which people often get wrong in exams. The key thing here is that it has nothing to do with whether 9.432 is closer to 10 or whether 10.659 is closer to 10. It has absolutely nothing to do with these two values. It is to do with 1.8 and 1.9, and this is how we decide. We need to know, is our value for x, is the real answer to the equation x cubed plus 2x equals 10, is the answer to that closer to 1.8 or is it close to 1.9? And this is the crucial step we have to make. Now, we know that 1.8 gave us an answer of 9.432, which was low. 1.9 gave us an answer of 10.659, which was a little bit high. In the middle of those, we have 1.85. Now, if we check 1.85, substituting it into x cubed plus 2x to see what we get, i.e. we do 1.85 cubed plus 2 times 1.85, the value for that is equal to 10.031625, i.e. it is slightly higher than 10. Now, that means that 1.85 was too high, 1.9 was too high, so all of the numbers in between 1.85 and 1.9 are going to give us values that are too high. All of the numbers in between 1.85 and 1.9 would round to 1.9 to 1 decimal place. However, look at here between 1.8 and 1.85. 1.8 gave us a value which was too low. 1.85 gave us a value which was too high. So somewhere in between them, there must be a number that actually gives us the magic answer of 10. All of the numbers between 1.8 and 1.85 will round down to give us an answer of 1.8. So the final answer to 1 decimal place is x equals 1.8. And the 1 decimal place is here in the value of x because 1.8 has been rounded to 1 dp. Another way in which people sometimes like to look at this is imagine you draw a line that represents 10. Now you know that 1.8 gave us a value which was lower than 10, so I'm going to write it underneath this line. I know that 1.9 gave me a value which was higher than 10, so I'm going to write it above the line. And I know as well that 1.85 gave me a value that was slightly higher than 10, so 1.85 gives me a value here. If you look, the crossover from low to high happens in between 1.8 and 1.85, not between 1.85 and 1.9, which means that the answer must round down to 1 decimal place to 1.8. Let's try another example. We're going to solve 3x squared minus 4x equals 11, and we're going to give our answer accurate to 1 decimal place again. So this is the equation that we are trying to solve, and this is our target. We're trying to make 11. So I'm going to set up my table again. Remember, I want a column for x. I want a column for 3x squared minus 4x, remembering that my target is 11. And then I want a value or a column for the comment. Now, the first value that I'm going to try is, the first value of x that I'm going to try is 1. If I substitute this into 3x squared minus 4x using a calculator, I'll get a value of -1, which is obviously much lower than 11. I'm going to write an L for low. I'm then going to go up by 1 whole unit. There's no point going into 1.5s, 1.6s at this stage. You need to trap your answer in between 2 whole numbers. So we're going to try and x equals 2. That's a logical thing to do. If we substitute this into 3x squared minus 4x, i.e. calculate 3 times 2 squared, take away 4 times 2, we get a value of 4, which is still lower than 11. Going up by a unit again, we'll try a value of 3. 3 times 3 squared, take away 4 times 3, gives us a value of 15. So immediately we are higher than 11. So we've trapped our answer in between 2 and 3. So again, as before, I'm going to go into 1 decimal place, and I'm going to try 2.5 first of all. Subbing this in gives me a value of 8.75, which is lower than 11. Now, because 3 was too high and 2.5 was too low, the answer must be somewhere in between 2.5 and 3. So it makes sense to then try 2.6. 2.6 then gives me a value of 9.88, which is of course still a little bit lower than 11. Now, because 2.6 was too low, and because 3 was too high, we know the answer has to be in between 2.6 and 3. So we'll try 2.7. 2.7 gives us a value of 11.07, which is slightly high. So now that we know 2.6 is a little bit low, and 2.7 gives us a value that's a bit higher than 11, these two values here, we know that the answer has to be somewhere in between 2.6 and 2.7. But remember, we want to give our answer accurate to 1 decimal place. Our value of x has to be to 1 decimal place. That means our answer is either 2.6 or 2.7, but we need to know if the answer is actually closer to 2.6 or closer to 2.7. So we're going to, as before, 2.6 and 2.7. We know that 2.6 gave us an answer which was too low, and 2.7 gave us an answer which was too high. We must now test 2.65, which is in between those two values, right in the middle. Testing 2.65 gives us a value of 10.4675, which is low. Now, 2.6 was low, 2.65 was low, which means all of the values in between 2.6 and 2.65 would give us values which were lower than 11. So the answer is not in this region here. However, because 2.65 gave us a value that was too low and 2.7 gave us a value that was too high, the answer is going to be somewhere in between these two values. All the values in this region will round to 2.7, so x is equal to 2.7 to 1 decimal place. If we try this using the other method, I'm going to draw a line that represents 11. This time I know that 2.6 gave me a value that was too low, 2.7 gave me a value that was too low, and 2.65 gave me a value that was too low as well. So you can see the crossover from low underneath to high above occurs between 2.65 and 2.7, so x is equal to 2.7 to 1 decimal place.